This tiny module can send data over kilometers, no Wi-Fi, no SIM card and barely any power consumption. In today's video, you'll learn how to use it with Arduino, and to make things even better, by the end we'll build a project that lets you control LEDs remotely between two boards. Before we jump into wiring code, let's understand what LoRa actually is, because once you do, you realize how powerful this little chip really is. LoRa stands for long range, and it's the go-to wireless platform for Internet of Things. It was developed by a company called Simtech, and its main goal is simple: connect devices that are far away from each other while consume very little power. Think about it this way: Wi-Fi works great for short distance like inside your house or office, but it uses a lot of energy. Cellular networks like 4G or 5G can reach long distances, but they are expensive and also power hungry. So what happens if you want to monitor soil moisture in 4 miles away, or measure equality in a forest where there is no Wi-Fi or cell tower around? That's where LoRa comes in. It is designed to send a small amount of data, things like temperature, humidity, or GPS location, over very long distances, sometimes up to 10 kilometers or more, depending on your environment. And it does all that using very little energy. That's why LoRa is used everywhere today, from precision agriculture and smart cities to environmental monitoring, industrial automation, and home automation systems. It's one of the main building blocks of the Internet of Things. Now, when people talk about LoRa, there are two key concepts: LoRa transceivers, which are modules like this one. They send and receive data directly, and LoRa gateways, which are bigger devices that connect many LoRa nodes to the internet, creating what we call a LoRaWAN network. In today's video though, we'll keep it simple and build a point-to-point communication system, just two modules talking directly to each other. Alright, enough theory. Let's see how we can use LoRa in practice with our Arduino. Before we go hands-on, I want to give a huge thank you to RYLR993, who kindly provided the LoRa modules for this tutorial. If you haven't heard of them yet, RYLR993 is a global provider of IoT communication solutions. They've been around for over a decade and offer a full lineup of products: LoRa, Bluetooth, Wi-Fi, cellular, GNSS, and more. Their modules are known for being high quality, easy to use, and affordable, which makes them perfect for do-it-yourself makers, educators, and even professionals. With distributors in every continent, it's really easy to get your hands on their products. So if you are working on any kind of IoT project that requires wireless communication, definitely check them out. I'll leave their link in the description below. Thanks again to RYLR993 for sponsoring this video and helping make STEAM education accessible to everyone. Now let's get back to the tutorial. Let's take a closer look at the RYLR993 Lite module. It has 5 pins: VCC, GND, RX, TX, and reset. VCC and GND are the power supply pins. The module runs on 3 to 3.6 volt, so never connect it directly to a 5 pin, you'll fry it instantly. TX and RX are the serial communication pins used to exchange data with your Arduino. The RX pin accepts only up to 3.6 volts, so you need a voltage divider to bring the Arduino's 5-volt signal down safely. The reset pin can reset the module to its factory configuration, but for this project we won't use it. You can leave it unconnected. One more thing, when transmitting, the module can draw up to 140 milliamps. That's a bit high for the Arduino's built-in regulator, but since our demo is simple, we'll power it directly from the Arduino's 3.3 volt pin. For bigger projects though, use an external 3.3 volt power source. Alright, now that you know how the module works, let's move on to the fun part, building our project. Today's project is simple, visual, and fun. We'll use 2 Arduino boards and 2 LoRa modules to send and receive messages wirelessly. Here's how it works. Each board will have 1 button and 1 LED. When you press the button on board 1, the LED on board 2 will toggle on or off. And when you press the button on board 2, the LED on board 1 will toggle. That means both boards act as transmitters and receivers at the same time, showing full two-way communication using LoRa. To build this project, you need 2 Arduino boards, 2 RYLR993 Lite modules, 2 push buttons, 2 LEDs, I'm using 3mm ones, 2 220 ohm resistors for the LEDs, 6 5k ohm resistors for voltage dividers on RX pins, breadboards, and jumper wires. Now let's assemble everything. Start by placing our Arduino and LoRa module on the breadboard. Connect the VCC pin of the module to the 3.3 volt pin on the Arduino and GND to GND. Then connect TX from the module to pin 4 on the Arduino and RX to pin 5. But remember, use 3 5k resistors as a voltage divider on RX. Next, wire the LED to a digital pin through a 221 resistor and connect the push button to another pin with one side to ground. Do the same for the second board, both setups should be identical. When you finish wiring, both boards should look exactly like the diagram on your screen. Now that our hardware is ready, it's time to move on to the software. I created a GitHub repository for this project. The link is in the description. Inside, you'll find 3 Arduino sketches: Setup LoRa, Device 1, and Device 2. Let's start with Setup LoRa. Open it in your Arduino IDE. This first sketch is designed to help us configure both LoRa modules using AT commands, special text-based commands that tell the module what to do. Upload the code to your Arduino and open the serial monitor at 115200 baud. Now type AT and press enter. If you see OK, that means your Arduino and LoRa module are communicating properly. If that doesn't happen, double check your wiring. You might have missed something. If you don't know how to use the serial monitor the right way, I have a tutorial on my channel all about that. Don't forget to check it out. Alright, back to our setup. Now type the following commands one by one. AT plus OP mode equals to 1. This sets the module to proprietary mode, used for point-to-point communication. The default mode 0 is for LoRaWAN networks. Next type AT plus band equals to 915.000.000. This defines the frequency band. I am in Brazil, where 950 MHz is allowed. If you are in the US, you can also use the same frequency. In other regions, the legal frequency might be different, so please check the LoRa frequency plan for your country before using it. Finally, type AT plus address equals to 1. This gives your module an address, kind of like an ID. You can use any number between 0 and 65,535, but each module in the same network must have a unique one. Once a module 1 is set up, disconnect it and repeat the same process with the second Arduino. The only difference is that you use AT plus address equals 2 for the second module. Now both modules are configured and ready to talk to each other. By the way, React provided a full AT command manual for this module. You can find it on their product page under the Downloads tab. It's a great resource if you want to dive deeper into what these commands do and how to customize your LoRa network even more. Now open device 1. This is the main sketch that runs on your Arduino. At the top of the code, we define some constants and variables, the button pin, LED pin, and some helper variables to keep track of button states and messages. In the setup function, we start serial communication with both the LoRa module and the serial monitor. Then we automatically send a few AT commands to make sure the module is properly configured when the Arduino powers up. If you take closer attention, they are the same AT commands we sent in the previous sketch. You'll now be wondering, why send them by hand if you could have configured them through code since the beginning? Well, I wanted you to write them down for 2 reasons. Firstly, to understand what AT commands are and how to use them manually. Second, to understand the need for automating this task, as typing commands one by one isn't practical for larger projects. Moving on, in the loop function we have the main logic. First, we check if the button is pressed. If it is, we send a small text message through the LoRa module to the other board. Then we check if our module has received any messages. If it has, we read it, verify where it came from, the sender, and if everything is right, then change the LED state. Turn it on if it was off or off if it was on. If you're having trouble understanding this sketch or wish to code with confidence, I have a tutorial all about Arduino programming. In this 30-minute masterclass, I will teach you everything you need to know to advance your Arduino sketches. Don't forget to check it out. Now upload device 1 to the first board and device 2 to the second one. Both sketches are almost identical, so I won't explain the second one. When both boards are uploaded and powered on, you are ready for the test. If you enjoyed this project, I have something exciting coming up. I'm preparing a masterclass on how to build drones with Arduino. This won't be for complete beginners. You'll cover advanced topics like flight control, 3D printing, PCB design, and much more. I created a waiting list for those interested. The link is in the description below. Sign up and you'll be the first to know when it launches. And that's it for today's tutorial. Remember, LoRa is what allows your Arduino projects to break free from short-range communication. With this technology, you can connect sensors across entire farms, forests, or even cities, all using just a few milliamps of power. If you learned something new today, don't forget to like this video, subscribe, and turn on notifications so you won't miss my next Arduino project. And if you want to keep learning right now, check out the video appearing on your screen. I'm sure it will help you take your Arduino skills to the next level.